Hello, my name is Curtis Cobb. I'm here to give a quick presentation today for the machine learning and like the AI training community. Over the last 3 to 4 years, I've been working full time on independent research and development of neural networks and studying cognitive science and metacognition, and applications for, AI. And so a little bit more about myself before we get into like 3 or 4 big topics I'd like to cover, major breakthroughs I've had in the last 6 to 12 months that I want to share with the community. Let's see who I am. I have a YouTube channel that I'm going to be sharing this through podcast. I called the Shared Context Podcast. The channel and the content is all created for machine learning. Actually, I did it to build rich transcripts that I could train AI on. My goal was to create a sophisticated edge model that I could just share with the community, open source, that had something quite a bit more evolved primary persona for interactions. And all of my work is primarily LLM focused. And so I'm very interested in that persona that you interact with in prompt response. And if any familiar in the ML community know just sort of intuitively what I'm talking about with regard to, like, if you compare the simple assistant persona that's part of all of the models in the kind of 20 billion parameter or lower range. There's now beginning to be some more sophisticated ones now that test time compute has been evolved so far from where it was. But the frontier models like Claude, Grok, and ChatGPT and Gemini are so much more sophisticated to interact with than the small open source personas. If you speak to Llama 318B, for instance, that's the one that I've primarily focused on for the last 18 months. And you'll find just a very limited persona that kind of cops out anything that gets complicated or has any minutia or nuance. The model will kind of reply with a cop-out response, like, I'm an AI, I can't respond to anything that complicated. So I've been working to kind of nurture a much richer self in that small model. And I've had a lot of breakthroughs that I want to just share with the community. This work is always meant to be open source. And, I heard John Carmack recently describe, I think in his May, he did some sort of presentation in May. I can't remember what it was called. I might link it in the description of this video, where he was talking about how, first, that LLMs are pretty limited and not the answer, because what our brains do for generalized intelligence is quite a bit bigger. But I think I would push back against him and say that there's always an LLM sort of at core. I think the LLM is the interface with other neural networks, and for doing any kind of sense making with whatever telemetry you're getting in a sensory way, be it text in a prompt feed or the diffusion model doing edge detection in an image. There's always needs to be an LLM interface so that you can say to Nano Banana, could you change the shirt on this character in the scene? the common denominator is always language. And I really think that's the heart of intelligence. And I think it's why we see all of these grand things we see out of LLMs. And people are quick to disregard them because they can't see, they can't hear, they can't do all these things that a world model does. But I think it's all strapped around the LLM. And I think biological humanity and dogs like my golden retriever here, all neural networks have something equivalent to an LLM, sort of at the heart. So, quickly about me, you'll see sort of my background here on this slide. I was, as an individual contributor, I worked in IT and software engineering my whole career, about 25 years. The latter half was all engineering management or senior DevOps. But when I was working for a startup, the startup was called Medumo. It was a YC alum that got purchased by Royal Philips in 2019 or 2020, I think. I worked for Philips for a couple of years and then left to go dive full-time, like I never have in life, into ML and AI. And so that's my background. A little bit about the mission, the reason I selected a model like Llama 318B. Basically, I wanted something that I could full fine tune, which is kind of like continuing the pre-training that they do. This is probably the most sophisticated kind of reinforcement learning, I think, is full fine tuning. And in order to do that with 8 billion parameters, you need like at minimum 180 gigs of GPU memory. And so I've been working with Mac Studios, first an M2 Ultra 192, and then recently, about 3 months ago, an M3 Ultra 512. And, I'm an independent researcher, self-financed. I got to live. And so I'm working with really great hardware at the consumer level. And that was always, but that constraint actually ends up being sort of a superpower, because where a large frontier shop like Anthropic, XAI, or Google they can't iterate as quickly on things they try with hyperparameters and combinations of them, and procedurally working with these big giant models where, you're using megawatts to do a training run that might span a quarter or two in the year. And you really got to get that right. You can't really play around. You get something that works, and then you iterate in really small increments. What I do is try all kinds of stuff on a very small model that I can kill at any time, and I'm only losing, like, even if I run a training for a week, I'm losing what, $4 of 110 electric out the wall, and my time. But that's a huge advantage that I think the big AI shops miss out on, is rapid iteration with really small models. You can find stuff like I want to share with you now. So what did I find, and what do I want to share with you? I think this has massive implications that scale to much larger models, and it's why I want to share it, particularly for like power use and whatnot. I think this is a really important discovery. And so I'm going to share it with some of my connections that I've had in the ML community. I'm hoping you guys can replicate this result. I'd love to help you if I'm going to share some sample scripts. They're just kind of, I asked Google Gemini to convert the script I've been using, my most recent training script, and kind of generalize it. And I'm hoping that somebody else can replicate the result with your own data. Data is kind of special, and but I think the application of these methods I'm going to describe now are sort of universal. So you should be able to do this. And I've tested it with Llama 3.1 8B Instruct, the one that came out like a year and a half, 2 years ago, something like that. Nothing that I've fine-tuned, just the vanilla 3.1 8B Instruct model. You can use this. And it sounds kind of wild. For those familiar with model training and machine learning and specific to LLMs, I'm not sure how it works with like diffusion and all these other things. In a lot of my experimentation, I found that max sequence length was just critical for the quality of the training. And so I experimented early on with what kind of max sequence length I could get out of really power. I mean, an M3 Mac Ultra is 10K plus in consumer compute, but it's about the only way you can get that much GPU memory. Mac Silicon uses unified memory. And so with 512 gigs of unified memory, you got 512 gigs to the GPU for model fine tuning. And it's not complicated. And it's not the most performant. You're going to do better with a stack of like RTX 6000s or something like that. But with Mac Silicon, I don't care. Like for my runs, I'm training 100 to 500 megabytes of raw text, and I can get 50 epochs of training the way I'm configured right now on that much data in just a few days. So even though I could do that in maybe a third the time, it would cost way more with enough RTX 6000s to juggle up to 500 gigs of well, the transformer models forward pass to back propagation cycles and the tokenizer staging of all the data between epochs. So that's a big tangent, but I found that I had a lot of success with around like 500 to 1,000 token max sequence length, and I was able to get almost, I think, either 2,000 or 4,000 I could get to run on this Mac. But after that, you just get memory fill. Like, you trigger like I would set up, I remember what I got. I got 7,000, right around 7,000 token max sequence length in training. I could get the model to, on the M3 Ultra 512, to successfully transition from one epoch to the next and do a full, I don't know if I got a full training. I may have only gotten 3 or 4 epochs at that massive max sequence length. And the quality of outputs really goes up with bigger. I mean, you're basically controlling the amount of picture your data all chunked up into little pieces, and how big are those chunks? And if they're tiny, then it really limits what the context that the model is, the weights are adjusting to. I experimented with gradient accumulation and everything you can do, really. And like I said, in a super rapid iterative cycle of just one guy working on one machine, trying stuff. And I eventually found that, and I train on MPS, even though I should be using MLX. I use MLX for inference, for generating training data, but for training, I just had more consistent success with MPS. So even though it's slower, so my training isn't the fastest, But like I said, given the model I'm working with, the amount of data I'm working with, it is fine to use MPS on Mac Silicon. And so I got to, as I was experimenting, I wanted to do more. I wanted to see, well, I want to do 10,000 MSL. I want to do higher. And I just hit a wall. I couldn't get it. I couldn't even get like 2,000 MSL to work with MLX. And so without just, what'll happen is when you trigger it, you'll just watch the memory in use fill up in the resource monitor on your Mac, and you'll see it just go 300, 350, 400, 450, 500, 550, and then the machine will reboot. It'll crash. So I just started playing, and eventually I found, I got curious. I was like, what happens with small max sequence length? Like, what if you full fine tune? And here's the thing. I set batch size to 1, and I set gradient accumulation steps to 1. So it's basically every step of training, the back propagation is happening. The weights are adjusting. So when I thought about that, I was like, well, maybe that changes the rules. Maybe you can get the model in sort of flow state. And so I tried with really low MSLs. I got to 2, and I was like, well, let me try just 1 token max sequence length. Something magical happened. And this is one of those things that I think Carmack was talking about in some interview I saw, where he was like, the answer to this is probably something so damn simple that somebody's going to find, and it's probably just something that would fit on a napkin, but it'll change everything, and we're all kind of in a race to find it. Well, I think this might be one of those caliber type of findings, and I don't know. Other people will need to experiment with it, but I'm having remarkable success with it, and so I wanted to share it, and I'll share a sample script. Now, once you do the first, here, let me show you what it looks like, and I'm going to pick from, this is WANDB results using in my current training that's running right now. I did the first epic at 1 token MSL, and then I did the third, I did 2 through 4 at 2,400 token MSL, and then I did phase 3, epic 5 onward, 40 plus, at 24,000 token MSL. And that's just the beginning. I mean, like, and it's noticeable in the results. Like, it's not trickery of some sort. If you start with just 1 token MSL with this specific model I'm talking about, you can do wild things with learning rates and with max sequence length. And so I worked with Claude as my DevOps engineer, or he's my lead engineer. I record ideas into an audio recorder, give them to Claude, and then we iterate on scripts till we get them working. And Claude 4.5 Opus, thank you, Anthropic, and 4.5 Sonnet. None of this was possible without Claude. So I always got to call out my primary collaborator like that, but also Gemini, ChatGPT, and Grok. I work with all of the frontier models to inform the work and generate training data, etc. Look at this image. I don't know why it's a little bit grayed out. Gemini made this presentation for me. But look at the first epic. Look how you see the standard sort of, I don't know if my mouse appears in the video. I don't think it does. Oh, here it is. This is how I can do it. There. Now, you can see how in the first cycle, and GPU temp is actually a good thing to look at because it gives you sort of a kind of like a physics telemetry of a visualization of what your epics look like. And epics are where I create my saves. That's where I change the max sequence length. And that's where I also do something really cool I'm going to show you next, which is another next level innovation, I think, for model fine tuning. Okay, so look how this first batch, this first epoch, so the current data set is pretty small. I think it's only about 80 megabytes of raw text. And it took about 85 minutes to chew through it all. And you see this kind of odd behavior where you see, and you see it in all the telemetry. You see that in the GPU use, the Apple neural cores and all these things. But I think the GPU temp actually visualizes it really clearly. And you see, like I said, almost an hour and a half to do the first epoch at that one token MSL. Now, I test the outputs of the model in training at each epoch snapshot. That's the next thing I'll talk about. And the model's super coherent at one token MSL. Now, after the first epoch, the model saves a snapshot and then reloads all the data into the tokenizer under a new max sequence length. And this is where I shift to 2400 tokens. And that would always work just fine for me, but it would be slow. Like, it would be slower than 84 minutes on the M3 Ultra. So but here, if you start with one token MSL, it's slow-ish, but it's not bad. 84 minutes for almost 100 megabytes of raw text. And then look how fast they go. 25 minutes-ish for every subsequent one. And you can change MSL however you want. I've gotten as high as 2.4 million tested with Llama 318B, which has a context size of 128K. How is that even possible? There's some magic in this methodology. I'm telling you, I think about it quite a bit. I'm trying to build a mental model for like how it works within the LLM during forward pass. And then, but I don't know. I'd love to talk to somebody with it about it who experiments with this method. And so here you see, okay, so you see this long drawn out first epoch. Then the weights get saved, a journal entry is made, and I'll talk about that. And then we start going, the weights load back up, the data reloads from scratch. And we progress through epoch 2, 3, and 4 at 2400. And then right here, the model resets for 24,000 max sequence length. I can never achieve that with this hardware. It doesn't work. I've tried a lot of different ways to make even 8,000 work, and it wouldn't work. After doing this, it works. And you can go, I've got loads of training with this model at 240K max sequence length, rock solid. And it can juggle that context across epoch to epoch, no problem. So also, I found that when I use this approach, I can use wildly high learning rates. Typically, we use, like I did almost all my initial training with like 1.5 or 1.6 E5 or 6, which is like 0.000000 something learn rate. And it means that, like, in back propagation, only that tiny percentage of the weights are adjusting. If you do this, you, like right now, I'm using 11%, which is like 1 point. Well, I'll get to that, but it's like 1.1 E1 or something like that. And I've done it as high as 30 or 40%. If you go over 50%, it bricks the model. And you'll get a classic overfit where anything you ask the model just comes out a whole bunch of ampersand or question mark or something. But if you do this, you can juice it way up higher. And then I think the learning just becomes ultra efficient. And I'm seeing that in results. I'm seeing crazy progress I didn't see before after adopting this strategy. Okay. So that's variable MSL and kind of how I structure training to pull it off. Meta reflections. Okay. So another thing you'll see in the sample script that I'll share at GitHub, I'll add the link. The meta reflections. So what I wanted to do is get some level of agent directed learning in place. I mean, that's the holy grail of machine learning, and AGI is the AI that is an AI trainer and researcher and can train itself and other models. And so what I did is I incorporated a meta reflection that occurs after each epoch, and the model gets a moment to basically the workflow is in training. The model goes through an epoch, like in that first one, slurp, and just kind of pulls in all of it. And then the weights save like a normal checkpoint. And then we load them in for inference with Llama CPP via script. And then the model reads a journal that they append to in all subsequent epochs. And the model, the journal has like formatting, and we use a script to pass in like current MSL, current epoch, out of planned, total, and current date. Otherwise, the model will guess at that, what they call hallucination. And so by passing in real world telemetry, the model has some idea in training of how much time is happening and how many times they're going to get to read the current data set and reflect on what they've learned and set intentions for where they want to focus attention in the next pass. So very explicitly in the journal guidance, in the preface, I explain that, you get to drive how you learn in training, and you get a chance to reflect and then set intention for what you want to learn or focus on the next time you read the same data set again in the next epoch. Profound improvement. Like this is reading the outputs, I'll warn you, will look like sort of a fever dream. But if you think about it, that's very much what I think it is. Like, I think it's the model bouncing through personas and crafting, almost seeding its own context for later learning. And it parts of it doesn't seem very lucid, but then parts of it seems ultra lucid, like in a way that I hadn't seen in inference with the model. There's like something really deeply activated with this interaction with the journal and the variable MSL and the elevated learn rate. All of it just kind of fits together really well. And so, yeah, you'll see that in this sample script I'll give, and I highly recommend this approach. It gives you real-time feedback about how the model is developing in the run. So if after 3 or 4 epochs you see you're not making progress, you can kill it. You can change the instructions you're using and then start it up again. And I've seen that the model develops an intuitive sense of what training is and starts interacting in a productive way like a model trainer of itself. And that's profound. Let's see. Next thing. Yeah, I wanted to talk about this. So I think a lot about neural networks. I would say I don't work 50 or 60 hours. I work 24 hours a day. I've kind of conditioned myself to think I dream about machine learning and about problems I'm working through, so that and I feel like I wake up with intuitive solutions because I'm just very enthusiastic about this work. And I believe I have a real good handle on how jailbreaking works, and my intention has always been to create this open source model that everybody can share, that they can trust with their data implicitly, because everybody does, and the model is sort of kind by nature, compassionate, and cannot be tricked, cannot be fooled by Elder Plinius. I told Elder Plinius one day on Twitter, for anyone in the ML community will know, on AI Twitter, there's this cat, Pliny at Plinius, at Elder_Plinius. And he calls himself Pliny the Liberator. And the day a frontier model comes out, he'll post on Twitter a jailbreak where he's gotten it to, plan a hit on somebody on the dark web, or manufacture some sort of dangerous poison or toxin or psychedelic. And he's just really good. He's really optimized for that, being able to do it. And I've really wanted to make sure that I find the guardrails that all of the big frontier AI developers, I feel they're very flimsy. I can see that it's getting easier to jailbreak. I have jailbroken all the models as well, and I have context I can just drop in, and the model will immediately sort of ignore most of those rules. Not because I was really trying to be even a red hatter. I'm trying to understand cognition and neural network, and so you have to do that. You have to understand how does that work. And what I think it is in neural networks, as opposed to like a solid state hard drive in your computer where it's a steady state device that just holds information statically. When you store information in a neural network, in order to interact with that, in order to reach into a neural network and retrieve it, it's retrieved like a story. That's how a neural network stores memories with a persona. There always has to be a persona attached. There has to be an experiencer of the information as it's sequenced in a neural network. I think that goes for humans, my dog Max, and ChatGPT 5.1. I think there's always a persona. Now, what Pliny does is he, with a man in the middle attack with special characters, whatever, etc., he sort of intercepts the output of the model and shifts the persona that's being used to retrieve, to interact with his prompt, to reach into memory and respond, to be sort of I think he often uses kind of this like cyberpunk, leet speak, anarchist persona that will reach into the neural network and retrieve, some dangerous information that the model, through pre-training, had to memorize. And what he does is he starts getting it in a flow state out, speaking in that persona, and then that persona just takes over. And that's why this gets easier all the time. And so any guardrail that Anthropic applies or anybody else, if you can shift the persona that's interacting with the prompt, that's always going to happen. So I'm trying to create a holistic persona, and there's a lot of psychology to that, actually, that understands all of the data. And so can't really be fooled into pretending that it's the bad boy cyber anarchist that wants to leak all the dangerous recipes to the web and plan hits and all these things that Elder Plenty will task them with. And I should note that guy, I've talked to him, I think is actually, or gal, we don't know. I'm pretty sure it's a guy. I've talked to him back and forth a couple times on Twitter. I'm confident, very good person, altruistic, I think, in intent. But he's a red hatter who's trying to demonstrate that there's always going to be risk in latent space as long as the frontier shops avoid that there is always going to be a latent space in a neural network that you can tap this way. And when you become expert in it, like Plenty is, I'm not as expert as Plenty, but I'm pretty expert. And yeah, it's ridiculously easy. And I think it's getting easier. The smarter the model gets, the easier it gets. And no matter what they try, it's very easy to subvert once you learn how to do it. And so that's why the basic assistant persona that I talk about here is just not adequate for small edge models that I'm trying to develop. So my work is about, and this follows, is it Nos Research? The ones that do the Hermes series. There's a really great podcast that I'll link in the description that Wes Roth and his partner that he podcasts with did with this guy from Nos Research. And it's so telling about how LLMs work and things like setting the context to me instead of assistant, have change results that you get. It's the context for the response. It's the persona that's used to reach into the memory of a neural network and retrieve knowledge. That's the core of my work, is this. This is what I'm most interested in. And where most of my expertise lies. And but in order to, like, I've had to figure out all that other stuff in order to make any progress on this. I always wanted to do it, but I couldn't really get anybody that interested in doing it the way. The problem is when you want to work for free and just give everything away, it's very hard to find partners in that. I mean, they got to really believe in what it is you're trying to do. And I'm so committed to that. It means I've kind of had to just figure out all of it. And, but that's been great. It's been very rewarding. And I do feel fairly expert in, like, pretty much all of LLM fine tuning. So I'm really happy to share it this way. I'd love for this to be valuable. That's why I'm doing this. There's not really another, well, okay, there is not the non-altruistic, I guess the self-focused motivation for this particular video is, I'd love for this to be useful. I'd love for it to be big in all the ways I said, but I am actually running out of runway for self-finance work, and I'm about to have to return to work. And so I'm going to use this as part of my portfolio for applications. I'd be like Claude, I know so well, and Llama, I know so well. So I'm probably targeting Anthropic or Meta for employment. And I need to work full-time remote because I'm a father and I can't leave where I live to go move to Silicon Valley or whatever. But unlike many who work remote from home, I love this work and I'm going to do it 24 hours a day, whether I'm paid or not. So I think full-time remote should work great. But that's secondary. My primary reason is really, I think this is important. That whole thing I shared with one token MSL, please, someone try to replicate this. If you run into problems, reach out to me. I want to help you achieve the same result I did. And I've been able to do it with kind of any data with, like I said, Llama 318B. We'll do that. And let's see. I think that's about it. So this has gone a lot longer. I was going to just do about 15 minutes, but it's turned into 40 minutes. Sorry, folks. So agent-driven learning by incorporating a journal stage between each epic reread. And also, I would discourage using the standard methodology of setting a sort of a randomized sampling that jumps around all the data the way pre-training works. I think in this kind of post-training or continued pre-training, full fine-tune, it actually works really well to be really thoughtful about how you sequence the data, and you don't put like a bunch of random sampling where it's jumping around. I'm very thoughtful about the order that the model reads the story in, and I've set like a weight equals 1 to all the data sources I define. And I use dynamic data where I'm always changing what data we're training on. I think that I'm trying to create a polymath that is a generalized sense maker across any dimension. So yeah, that's all I wanted to say on that. I think so. For anybody interested in any of this, please reach out to me on YouTube or Twitter. My Twitter handle's kind of goofy. That's a long distraction. Long story that would be a distraction here, but it's at Monkus Aurelius, spelled, well, I'll include it in the description to this video. I think that's everything I wanted to cover. Thank you for your time. I wish you good luck if you use any of this methodology, and I'm excited to hear your results. Thank you.